Hello, and welcome to version 4.6 using the new vector dot product and vector cross product in the MathPac. We begin from the main menu by selecting the matrix editor. We'll have to enter our vector and let's give it a name. We'll just pick something simple. We'll just call it Q. And we want, let's do a 3D vector, so we'll want 3 rows and 1 column. And let's enter some values. I picked a problem from the book here. So the vector is 2, 5, and 1. Okay, we're done with that one. And now let's go back and see if we can build another one. So I'm going to back up here and then come back to the matrix editor and pick another name. Let me just pick A. Again, let's make it a 3D. Of course, it'll have to be if we're going to do the cross product. And its values would be -3, 2, and 4. Of course, these values correspond to I, J, and K. Now that I've got both my vectors entered, I'm going to go back to the matrix calculations, and I'm just going to scroll down all the way down to the bottom, and you'll see that right here, right next to the bottom, we have vector dot product and vector cross product. So let me start with the dot product, and I want to do the dot product of these two new vectors, A and Q. Of course, it doesn't matter what order I go in. It could be A and Q or Q and A. The dot product would be the same. And I just click calculate, and I see that the dot product is 8. There is a help for the dot product. And it just tells you that, of course, the dot product is just the sum of each cell from the first vector times the corresponding cell from the second vector, and it's only defined for 2-dimensional and 3-dimensional vectors, and that the answer is a single value, that is, it's just a magnitude. It's a scalar value. Let's back up now and do the cross product. Of course, the cross product is going to give me something different. It's going to give me an actual matrix output, and here it is. I see that I have -18, 11, and -19, and that's my cross product. There is, of course, a help again, and here it is, that V cross U is as follows. Is the magnitude of V times the magnitude of U times the sine of the angle between them. And it's only defined for a 3-dimensional vector. Of course, the resulting vector from the cross product is orthogonal to both the beginning vectors A and Q, and you can determine the direction of that orthogonal vector by using the right-hand rule. So this is how you use the vector cross product and dot product. And again, if I switch the order of these, you'll notice that it does give a different answer because I have switched the order of the cross product. So while the dot product is not dependent on the order of the product, the cross product definitely is. And so you'll want to keep that in mind when you're doing these calculations. And this ends the session on using the new dot product and cross product vectors.